first and foremost to thank all the attendees for joining us today on our FIPRES webinar. We really appreciate your presence here, and we would love for you to learn more as we go along for this hour session. Allow me to break down what will be, my name is Shen, and I'll be your host today. Allow me to break down the timing. So we will have 30 to 35 minutes of the presentation for FIPRES. We have another additional 10 minutes for the bomb evaluation guideline, which we have received a lot of questions in the past. And last but not least, we have another 10 minutes of Q&A. As for the Q&A, we would like to seek your cooperation to key in the Q&A tab below on the Zoom. There's a Q&A tab to key your questions there, and we'll get back to you via the chat during the Q&A session. We encourage as many questions as possible. However, if there are some questions that do not appear, please forgive us, because there's our people manning the team, the Fuji Britex team, which is Ms. Chong Lee Fong, Christopher Kwok, and myself. And our speakers today are from Streamer, Mr. Matthew Zink, and Sophia. So please put your questions in the Q&A, and we try our very best to get back to you. And if we can't, we'll get back to you in another way, via email or via another means. We do hope we can address every single one of your questions. So without further ado, let me introduce our Fuji Britex. Fuji Britex is actually started in 1970. We are 48 years old this year, 1973, and we've been around for 48 years. We're going to be 50 soon, and we have transcended from just a trading company, and now we provide energy storage solutions. And you can find us on www.britex.fujielectric.com for more information. Because I want to keep this short so that I can get you straight to the topic. Today we are in collaboration and in partnership with the Streamer Group. And today we have Mr. Matthew Zing and Ms. Sofia Pogorelova from the Streamer team to introduce us the fire and prevention and overheating control system called FIPRES, which is a revolutionary fire prevention system for mainly switchgear. Mr. Matthew Zing has been in the electrical field for more than 20 years. He has educated himself very well, and I think he has done a lot of publications in 4 publications in international conferences that will be able to help us answer these questions for FIPRES. Ms. Sophia has also joined us in 2021, and she's also has 2 degrees in power engineering, which will also help us in this education of FIPRES to you guys. Streamer is an international company with HQ in Switzerland. They have offices in UK, China, Russia, and 5 main countries. FIPRES is not the only product they have, but they also have lightning protection devices for MV and HV overhead lines, moisture monitoring and drying solution for power transformers, and a new surge arrestor monitoring device coming in 2022, which we are very excited to do the next webinar on as well. Without further ado, I will hand over this presentation to Matthew, who will kick us off for why we are here and why FIPRES is here for. Thank you, Matthew.
Thank you very much, Shen. So just a second, I will share my display. So let's start with basically the reason of FIPRES to be is that there's a lot of fires created inside the buildings by malfunctioning of the electrical switchgears and panels, and that represent a serious amount of loss and damages every year, which, for example, have been evaluated at $3.2 billion US in US and in Europe. So for this reason, they needed to be some solutions evaluated. So the reason of these fires and of course overheating in the first place can be multiple inside switchgears and switchboards. The most common one is loose connection, but also aging of the equipment. So what we mean by aging is basically switch gears, for example, when they get under a certain number of operations, get their contact resistance increasing. So they overheat. Then you will have arc faults, insulation failures, overloads, or improper selection of equipment. So for example, when your switchgear is it does not carry or does not have the rating according to the current it's carrying. So for these reasons, for these problems, loose connection, aging, and improper selection of equipment, FIPRES is one of the solutions that can be implemented inside your switchboards. For the other reasons mentioned, there are devices currently available on the market and that do a far better job than FIPRES for it. So we're just going to spend a bit of time on loose connections because it's the most common reason. And loose connection comes from improper torque. From corrosion, vibration, temperature, and current cycling. So we will just give a few insights on how corrosion and overheating happens on the contacts. So basically, when you start from a situation where you have a mechanically loose connection, you will have overheating because basically the less the pressure, the higher is the resistance. So if you have a higher resistance at the contact point, it will basically work like a heater. And this will lead to oxidation. And so the phenomenon of oxidation is described here in the curve. If you take a copper contact at 100 degrees, which basically is here, it's written here, at 100 degrees, and you leave it at 100 degrees, which is basically the thermal limit that is given, for example, for terminals in Australia, 105 degrees. You leave it for a few hours, you can see that the resistance, the contact resistance is increasing and increasing in a strong magnitude, including, for example, after 100 hours, 10 kilo ohm. So this is due basically to the oxidation phenomenon. And then this you can see through the curve that basically you enter into a thermal runaway, and that generally leads to fire. So that's the most common scheme of fire and overheating happening. So for this, there are different solutions available on the market, which we present you a brief outlook. So one of the solutions is, of course, to have a proper fire system, which is mandatory. The issue with the fire system is that it's not preventive. One of the goals of FIPRES is to be preventive. The fire system usually reacts once there's a smoke. So once something is already on the fire and is potentially damaged. Of course, the fire system is continuous. I think that we cannot consider it as affordable in the sense that it's requiring quite a number of wiring, equipment, monitoring system, and so on. And it's definitely not easy to retrofit. Then one of the mandatory actions in most of the countries is to have infrared thermography. The infrared thermography is of course somehow preventive if you do it regularly, but it's definitely not continuous. It can be regarded as affordable and easy to implement, although you need to open the panels and sometimes it's not always very secure. Then another solution is, of course, to use sensors. There are various types of sensors available on the market, whether it's corded or wireless. Of course, they are preventive because they allow you to monitor the temperature and sometimes very accurately. It's continuous, and it's not always very affordable and not always very easy to implement or retrofit, especially when it comes to corded sensors. And finally, this FIPRES. So the idea of FIPRES is really to be preventive, continuous, affordable, and easy to implement and retrofit. So how does it work? FIPRES comes in the form of a sticker first that you need to wrap around the conductor or the bus bar. And then this sticker will present different level of temperature, the thermodots, which are 50, 70, and 90 degrees here on the picture. And then whenever you reach 70 degrees, or 50 degrees, the thermodot will turn black, and this is non-reversible. Then at a temperature of 100 degrees, the sticker will release gas, and this gas will basically be sensed by an electronic device that is located within the same compartment as where the stickers are, and that will trigger an alarm. So this electronic device has a dry contact output to send it to an alarm in form of a buzzer, of a light, and has also an RS-485 Modbus communication capabilities that can be sent either to a centralizer or concentrator, and that concentrator can be connected to your BMS or to your SCADA system or to your alarm system, or it can also be done directly. The device, the sensors, the FPA can be directly connected to the alarm system or the BMS via the RS-485. So that's the general principle of how it works. So here is a small video on the operation of FIPRES. So here you can see on the top the fire prevention alarm system, a breaker. So here what we do is that basically the bus bars are heated by a heating element that we hide behind the bus bar. And on the right side, you see a thermometer that gives you the current temperature on the bus bar. So right now it's 40, 41 degrees. And my colleague is basically setting a sticker on the bus bar. So he's not completely wrapping it around because for the sake of doing the demonstration, we don't need. And here he's turning on the breaker. That is basically turning on the heating element, and you see the temperature increasing. So now we are reaching 50 degrees and the first thermodot has turned black. And so we're waiting now for 70 degrees for the second thermodot to turn black and indicate us that we have reached this temperature. And so the temperature will increase up to 100 degrees. At 90 degrees, there will be the third thermodot turning black. So we're reaching little by little this 90 degrees. Now we reach 90 degrees, the thermodot has turned black. And then by 100 degrees, the sensor, there's a LED on the sensor, will turn red on the top sensor, and the breaker will trip. Yes, so the dry contact output of the sensor, now I will show you here. Up here, the LED has turned green, and the dry contact of the sensor has closed and leading to the trip of the breaker. Of course, you are not. You can connect it to. You don't need to trip the breaker. You can simply turn on an alarm. Again, it's a prevention system. It's not necessarily meant at triggering a breaker. So let's have a close look at the overall how do you say, degradation of contact and how the fire really starts. Usually the degradation occurs within months and with different temperature cycling and always reaching higher temperature. And then once the contact are really degraded, in a few minutes, it can lead to fire. A few important points to understand how FIPRES is secured is first, by understanding that the real fire really starts rather above 200 degrees and not at 100 degrees. At 100 degrees, you have a degradation of contacts, but you do not have fires. And that's the point of doing prevention at this temperature and monitoring carefully this temperature, because at this stage, it's possible to repair. And this is precisely what FIPRES allows you to do, is that at a temperature of 100 degrees or even before, so months before the degradation or the dangerous situation, you are able to repair your equipment. So we have, so FIPRES is composed, as I mentioned before, of stickers and as well of electronic sensors to sense the gas of the release by the stickers. These stickers come into different form factors. So there are very small ones that are dedicated to a smaller conductor, 1.5 square millimeter, 2.5 square millimeter, and so on. And then very large ones that are dedicated at bus bars. So there are two reasons why we have different sizes. One, as you might understand, is the size of the conductor. The second one, it's because of the size of the panels. So the stickers and the sensor need to be located inside the same compartment, but the sticker needs to hold a certain amount of gas that can fill enough the panel so that it's been detected by the electronic sensor. And basically, we have different level of activation that can be chosen at the moment where you place the order, and it can be 80 degrees, 130 degrees, or 100 degrees, as you can see here. So a lot of questions came to see whether people were wondering whether the stickers were catching fire. So basically, the answer is no. The stickers are made of fire retardant material, or they are fire retardant. And here is a small demonstration that I did at the office a while ago, where basically we use a lighter, and I try to burn it out, so it can take a while, but basically it's not catching fire. So I do my best, but it's if you look at the whole video, it lasts quite a while. So the second part of the system, apart from the sticker, is what we call the FPA, or the fire prevention alarm. So this device is meant, as I mentioned before, as catching the gas coming out of the stickers. So I didn't mention, but the gas coming out of the sticker is an inert gas. It could be very similar to a gas that you find, for example, in switchgears, in medium voltage switchgears. So it's definitely not flammable. It's not explosive. It's environmentally friendly. So there's no risk for your installation related to this gas. And we have installations in oil and gas plants. So the gas is being sensed by the FPA, and the FPA that you can see here, we have two types. We have a type where we have a single FPA that is meant at one compartment, and then we have an FPA composed of 4 coded sensors that you can place in different compartments. So the reason for having different FPAs is one, for the volume of the compartment we are dealing with. So basically 0.1 cubic meter to 4 cubic meter. And the second reason is for you to be able to reduce the price points. So as I mentioned before, the FPAs are equipped with a discrete contact output and Modbus communication that allows you to connect it with the SCADA or the BMS. Huh? So here is another important part looking at security. So the FPA is constantly checking the ambient air inside the compartment. Basically, its sensitivity, the sensitivity of the electronic device is very low. It's about 10 ppm. And the threshold usually for a cubic meter is set at 150 ppm. So you might wonder what ppms are. If you are not chemist, ppms are part per million. So basically it's the number of molecule as compared to 1 million of these molecules. So the sensitivity is really low. You have 10 parts or 10 molecules for 1 million molecules. This is the minimum sensitivity of the alarm of the sensor inside the FPA. And then you can see that the threshold is far above the sensitivity limit, so like 15 times above. And if you look at, for example, a sticker of 14 centimeters long that we use for a 1 cubic meter compartment, it can generate up to 400 ppm of gas concentration inside the 1 cubic meter. So you can see that basically first, the sensitivity is very low. As compared to the threshold, which is way above, you have a large safety margin. And as compared to how much the sticker can release of gas inside the compartment, it's even threefold higher. So the safety margins that we take onto the overall systems are very high in order to ensure that the system works properly and that it is reliable over the time as well. And at the same time, our FPA has a system to auto-calibrate every 4 hours the setup. So we have another type of stickers that is basically a visual sticker, and it contains no gas. It's only meant at showing you whenever, like the thermodots, whenever you have crossed a threshold of temperature. So they come in different sizes as well, S, M, and L according to the conductor size. And they have different level of temperature activation. So some of our customers use them for capacitor banks, for example, with lower temperature, like 70 degrees. And they have 10 years of validity, and we have a series as well that can be used outdoor. So here I have a few examples of stickers on withdrawable contacts on medium voltage switchgears. So you see them directly connected close to the contacts. You can see them as well on the current transformer, same in medium voltage switchgears. Here you see inside the switchgears the compartment accorded sensor from FPA-4S, and the medium body, the main body located inside the LV panel of the switchgear. So here is a MDB of 400 volts, where basically the switchgear has been, terminals have been equipped with some stickers here, and then on top the sensors, the sensor for detecting the gas. Here is another medium voltage switchgear of 6.6 kV, where basically the sensors and the stickers are located close to each other with a concentrator inside the control panel. Finally, we have test equipments as well, because sometimes we need to either demonstrate or either fine-tune the systems. So for this, we have a demo case that you can see here on the left and that you've seen in the video just before. And on the right, we have testing liquids that you can use at the time of commissioning or annual inspection, and where you can vaporize basically the gas onto the FPA to be able to verify that it triggers the alarm system. Finally, the system FIPRES performance relies in the fact that it works earlier than existing fire systems. It detects overheating points. It's basically continuous. It works 24/7. It allows you to inspect as well each part of your equipment that you believe could be sensitive. It's easy to install. It can be connected to the SCADA or your BMS system, and it's got also a dry contact output to connect to external alarm system. So we believe it's the right solution for fire prevention inside electrical and electrical switchgear and panels. I will leave the mic to Sophia for the BOM evaluation guidelines, because basically we understand that to implement this solution, you need to have a few guidelines on how this can be exactly applied. So the point of this part of the presentation is for Sophia to show you how we usually evaluate each technical case, and what drives our conclusion, how to install and where to install the FPA and the stickers. Sophia, are you there?
May I start?
Yes.
I'm Sophia, Junior Product Manager for FIPRES system. I would like to tell you about Bill of Material Evaluation Guideline, how to choose the place for FIPRES system, and count product quantity. Next slide. There are 5 steps you should follow, which include assessments of the electrical panel, selecting type and location of gas sensor, selecting gas sticker and visual sticker location and sizes. Next slide. In assessments, there are 3 points you should consider: the volume of the electrical panel, the type of cabinet, open or closed, and the type of ventilation in the electrical panel. In most of the cases, gas stickers and gas sensor are installed, but in very specific situations, visual stickers are installed, and in these cases, please consult us. Next. I would like to focus that for the panel, we understand the board consisting of several sections. Section is one part of the panel, and compartment is one part of the section. To detect the gas, you should have gas sticker and gas sensor in the same compartment. Next slide. To select the type of gas sensor, you should know the volume of the compartment. Use single FPA-24X gas sensor for one compartment up to 1 cubic meter, and use gas sensor FPA-24 with 4 coded sensors for compartment up to 4 cubic meters. Next slide. Single gas sensor FPA-24X should be installed at the top part of a compartment, near and above to gas sticker spots, and obstacles shouldn't block it. Next slide. Gas sensor FPA-24 with 4 coded sensors is installed in switchgear with several compartments to decrease the price per contact. It has the same requirements for installation as single gas sensor FPA-24X. Next slide. For the case with merged compartment without internal partitions, install gas sensor FPA with FPA-24 with 4 coded sensors in each section. One section shouldn't be bigger than 4 cubic meters. Next slide. We recommend installing gas sticker and visual sticker on the following equipment. The first priority is incoming cable contacts, circuit breaker contacts, especially those with withdrawable contacts, cable feeders, fuses, and disconnector contacts, because these are the most significant equipment in the electrical panel. The second priority is voltage transformers, busbar connections, and current transformer contacts. Next slide. This is a cross-section of middle voltage switchgear. So we install gas stickers on busbar connections, especially those made on site, on moving contacts of withdrawable contacts of circuit breakers, on contacts of current transformer, on incoming cable contacts, and on moving contacts of withdrawable voltage transformer. Next slide. Selection of gas sticker and visual sticker sizes. Gas sticker and visual sticker sizes can be installed either on bus bar or on cable connections. Next slide, please. For gas sticker installed on bus bar, we check the cross section of it. For example, for 25/3 cross section, install gas sticker for volume 0.3 cubic meter or gas sticker for volume 1 cubic meter. Next slide. If the cross section of bus bar is big, use overlapping of 100 millimeters of 2 gas sensors, of 2 gas stickers. Next slide. For cable cross sections, we also have a table of correspondence, and depending on the size, different gas stickers are installed. Next slide. Here is a list of compatibility of gas sticker, visual sticker, and gas sensor. There are different volumes of compartments. Gas stickers are also designed for different volumes. If the volume of the compartment is bigger than the volume of the gas sticker, and the cross section of bus bar or cable is small, use visual stickers. Single gas sensor FPA-24X is designed for volumes up to 1 cubic meters, and gas sensor FPA-24 with 4 coded sensors is designed for volumes from 1 to 4 cubic meters. Next slide. Visual stickers have 3 sizes. It's S, M, and L. For cable cross section from 10 to 120 square millimeters, and for any bus bar cross section. That's it.
Thank you very much, Matthew and Sophia. Yes, I hope that the attendees have managed to get all that. Anyway, we are open to questions and answers. Please do type the questions in the Q&A tab beside the chat, and we will flag it up in the chat column beside, and Matthew and Sophia will answer questions. So for example, Matthew, can I have the next slide?
Yes.
Yeah.
Just a second. Okay.
Okay, so Matt, can you help us read the question and answer, and Sophia do the second one? So we'll be in this vein, so the crowd will know how to answer the question. Please go ahead.
So one common question that is asked is FIPRES applicable to both low voltage and medium voltage? and if medium voltage up to what voltage. So yes, FIPRES is applicable to low voltage and medium voltage switchgear or panels with theoretically no voltage limit, but currently our highest installation is 35 kV. So Sophia, you can take the next question.
What is another question which we are asked is what is the color of the label and is it only yellow? Yes, we decided to make it only yellow because there are various worldwide norms. So per December 2021, we decided to supply only yellow ones.
Okay, so now we will switch to the questions that were posted inside the chat. So one of the first questions that was posted is what is the difference between the new FPA and the old FPA? So basically on the new FPA we have reinforced the EMC capabilities. We have added the front display that allows you to set the thresholds or the volume of the compartments and therefore the threshold by yourself. On the former FPAs, the threshold was set at factory level, and you would buy FPA according to different compartment volumes. So now with the new FPA, you set up the volume of the compartment by yourself, which is it's more flexible on site to readjust things. So Sophia, I'll let you the second question.
How do we know what label size to use?
Okay, so I will move back to the slide.
Okay.
Sophia, so that you can. So I think this is the slide, yeah.
We choose the label size in. It's depending on the volume of a compartment in which you will install your gas sticker and gas sensor. And also it depends on the cross section of bus bar or on cross section of cable. So you should know the cross section and the volume, and you have these tables just to find the right size of gas sticker or visual sticker.
Okay, so next question is there an expiry date used by date for the sticker? So we'll move just back to the sticker slide. Just give me a second. So basically for the stickers, whether it's for the gas stickers and the other stickers, they are meant to have a 10 years validity period. Basically, the expiry date is written on the sticker at the time you buy it, and yes, it's usually 10 years from the date of manufacturing, and it's been tested inside our laboratory. So fourth question. So there's another question. You take the next question, Sophia.
How should we wrap the cable with rFPT? Can we make 2 turns? Actually, you should wrap the sticker in a circle, and it shouldn't be more than 2 turns because it will lower the sensitive. So you should only wrap it like in 1 circle, and this will be enough.
Yeah, it's recommended, just to add one thing, it's recommended that the sticker does a closed loop on itself to make sure that it's actually well sticking on each other and it's not going to move. So next question is Okay. It's good to see sensor checking with sample gas, arcing gas, taken care under threshold foreign gas in order to prevent nuisance stripping. Is there any bypass provision to check sample gas online instead of trip? Just give me a second. I just need to. Okay, so I understand the question. So the question is about nuisance stripping caused by foreign gas, and is there bypass provision to check sample gas online instead of trip? So yeah, I understand the question. So yes, so I will just go back on the FPA. So the question is about it's about the presence of other gases inside the environment of the panel or the switchgear that could cause the FPA to trip rather than the gas coming out of the stickers. So this is let's say not really a common problem, but it's a problem that occurred at the beginning when we were launching the solution. And this is the reason why we set up here, that you can see here on the display, our zero drift technology, which is basically a technology that takes into account the environment of the switchgear and the switchboard and sees that there's a foreign gas that is detected, that could be taken as being the gas from the sticker, and that could trigger the threshold. And this is the reason why this zero drift technology has been implemented, so that basically the threshold evolves with the environment. So basically our FPA will be triggered only if the triggering gas increase in a fast manner. So with a strong variation of the gas concentration. So if it's a small variation, it will not be detected, and if it's a strong variation, it will be detected. And again, the threshold will vary thanks to this zero drift technology. For you, Sophia.
Yes. Is it possible to check if the label is still in good condition? Actually, we apply quality control of rFPT mechanical characteristics for each batch of stickers, and of course do visual checking before selling. So yes, we test our product before. And of course, we supply Democase in which you can wrap the sticker around and check whether it works. Of course, you can check the performance of gas sensor also. This is what Democase are intended to.
So apart from the demo case, we will launch end of Q1 a new testing kit dedicated at this reason, to be able to check whether the label is still in good condition with a proper user manual, and that will lead you to how to do it. So next question is, besides switchgear, building chillers are okay. Now this is okay. To be honest, it's a question I wonder as well for a while, and but I lack of expertise in this field to know whether our products could be installed in these conditions. I believe yes, but I never had really the time to work on the question, and I think our product managers either. But we haven't had a case yet inside our list of reference in this sector. But we will be very happy to support you and do some analysis if someone has this case about building chillers. Sophia. Next one.
What is the time frame for this product to last to? It's 10 years. It's 10 years for stickers and also for sensors.
So yeah, I would just like to add a few things. I know it looks a bit mind-boggling, the 10 years, but basically we tested the stickers in various ways. For example, the gas, unless we reach, like for example, for 100 degrees gas, unless we reach 98 degrees, there is no gas that is released from the sticker. So you put the sticker at 50 degrees for 5 years, there will be no gas released. You really need to reach 98 degrees until the gas is released by the sticker. And this allows the sticker to keep the gas for quite some times. And 10 years is expected, knowing that our oldest installation are 4 or 5 years now. And as we go and inspect them, the stickers are still okay. So next question is, how can this be applied on MCC, which is made up of many started feeder drawers? Yeah, well, of course, this is the whole reason why we show you one of the slides related to the compartment. Where is this slide? No, it's in yours. Up. Well, this is not exactly what the what the question was meant for, but basically, yeah, the idea is that you need a sensor per compartment. Yes, when you have a wave drawable cabinet, it's way more complicated to implement the solutions, and yes, you need to put one sensor inside each of the drawer. So providing the fact that we could find a solutions for the drawers, I see no reason why it could not be implemented. The only thing is that the price point might be a bit higher than conventional panels, for conventional panels. Sophia, I give you the next question.
Is it possible to check the FPA without tripping the breaker, disrupting operation? Yes, it is possible. Just don't connect the dry contact output to the breaker. We have testing liquid, so you can spray it on the FPA and check whether it works or not.
Yeah, I think there's a just to bounce back, there's a misinterpretation on the video that we show. On the video, we tripped the breaker for the sake of demonstrating the dry contact output. In reality, again, this system is meant for prevention. So we detect it at 100 degrees, the detection and the alarm is at 100 degrees. At 100 degrees, there's no fire, as I was showing before. The fire starts much later. And the point is to do prevention, to be able to cure problems earlier than when the fire starts. So an alarm, usually connecting the dry contact to an alarm, whether it's a buzzer, whether it's your BMS, is enough. You do not need to trip your breaker. So as long as you connect your dry contact output to a light, a breaker, a buzzer, your BMS, sorry, not the breaker, then it's okay. You can test it and verify that the alarm is triggered properly. How often do we need to check the effectiveness of the FPA? So I would say it comes into your conventional maintenance procedures, which comes basically normally every year, as it is for the infrared verification. At the same time, you can verify the effectiveness of the FPA. Next question is for you, Sophia.
What is the maximum distance between the label and sensor I can place? Actually, there is no maximum distance, but we have the volume. It's as we told, it's up to 1 cubic meter or from 1 to 4 cubic meters. So the main thing that you should do is to place FPA at the top because gas is coming to the top. And of course, if you want to detect as much as early as you can, you place FPA near to rFPT spots. But of course, it's allowed to place them on a longer distance. It still works.
Yeah, it's really a matter of volume of the compartment and the size of the stickers.
Matthew, Sophia was on mute, so the last question I didn't think they heard.
Ah, okay. So
you didn't.
Question 11.
Yeah, Sophia starts again with the question. Yes.
Oh, sorry. What is the maximum distance between the label and sensor I can place? We have the limitation to the volume of the electrical panel. It's from 0.1 cubic meter to 4 cubic meters. If you want to detect the gas as fast as possible, you place FPA close to rFPT spots, close to gas stickers, then the detection will be faster. But the main point is to place FPA at the top of a compartment because gas flows to the top. And actually there is no maximum distance. You can place it and FPA will still detect. And you should choose gas stickers and gas sensor according to the volume.
Yeah, as long as you remain in the volume prescribed inside our guidelines, you are fine. Then the distance doesn't really matter. But of course, you need to stay within the volume and have selected your FPA and your stickers according to the volume and the prescription you will give.
So far, I think that's all the questions we have. Thank you, Sophia, and thank you, Matthew, for answering all these questions. If we have not answered them as accurately as you have wanted to ask, please do feel free to write in to us or just query us. We will try to get back to you with more accurate answers. We hope that we have enjoyed this presentation as much as we have enjoyed bringing it to you. We thank you for your time once again, and we hope that you join us again next time with more exciting presentations from Streamer and Fuji Bridex. Most important is this information will be available to all via email, and some of this information is already on our website. Once again, it's www.bridex.fujielectric.com. And if you have any other questions, especially question number, I think it's a multifaceted question number 8, how this can be applied on MCCs. We do have the FPA-4S, which can split the sensors into each drawer. However, the cabling portion is something that we can just do a short design so that we can put stickers correctly and with the right sensor, and we can put it to a concentrator, which will combine all the signals to your external monitoring system. This will require some design, and so therefore, please do send us your design in the files in your panels, so that we can create a design for you. That we provide as well over here at Bridex and Streamer, so you don't have to think about it, just let us know. And if we can discuss more on the design whenever you have a query. So without further ado, I thank you for your time. Thank you, panelists. Thank you, team, and thank you, attendees, and very much for joining us today. Thank you very much.
Thank you, Shane, for having us.
Thank you.
Thank you.
Thank you.
Have a good weekend. Bye.
Yeah. Good weekend, everyone. Bye.